Hi everybody. I wanted to do a quick example of graphing quadratics to help you if you were kind of lost on what we were doing. So what I have here on the screen is the graph of y equals x squared. And I found that the old-fashioned way. I took the x value and I found the y value by squaring it. Now, that's not the fastest way to make these graphs. In fact, we're going to have a much, much faster way. But we're going to notice some patterns in this graph that's going to help us work a little bit faster. So the first thing we're going to look at is the first difference of the y values. They have this pattern where to the right of the vertex we see 1, 3, 5, and to the left of the vertex we see -1, -3, -5. If you look at the graph starting at the top leftmost point, you can see that you go down 1, 2, 3, 4, 5 over 1 to get to the next point, down 1, 2, 3 over 1 to get to the point following that, and down 1 over 1 to get to the point following that. Continuing on, you go over 1, up 1, over 1, up 3, and over 1, up 5. All quadratic graphs are going to be related to this function, or this change. This is really powerful, and it's going to save us a lot of time. Okay, so we are graphing in vertex form only. So when you move on, this will be a little bit more challenging for other forms, but it's super easy in vertex form. Vertex form is when you have a set of parentheses that is being squared, and generally some sort of constant term out back, and some sort of leading coefficient that tells you the steepness. So the first thing we're going to do is identify and graph the vertex, -3, 6. We know that these functions are symmetrical, so we're going to draw in an axis of symmetry through there. We're going to identify our steepness. Now the steepness is always the number in front of the parentheses. Our steepness here is -2. Since that's negative, our graph is going to open downwards and look like a frown. If it was positive, our graph would open upwards and look like a smile. So the pattern for any old quadratic is 1, 3, 5, 7, as in over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. When I have a steepness of -2, instead of 1, 3, 5, 7, I'm going to have -2, -6, -10, and -14. So starting at the vertex, every one move over is going to involve that number up or down. So starting at the vertex, down 2 over 1, down 6 over 1, and then down 10 over 1, a little bit off the graph there. If this was a -3 instead of a -2, I would have done -3, -9, -15, -21, so on and so forth. Now, since these graphs are symmetrical, I'm going to plot mirror points. So here it takes 1 to get to the axis of symmetry, so there's a point 1 over. Here it takes 1, 2 to get to the axis of symmetry, so there's a point 2 to the left, and so on and so forth. So overall, our final shape looks like this. When we get really good at these, we can do these problems in less than 30 seconds, which is an awesome, awesome way to save time. All right, let me know if you got questions. Hopes that helps.